All right, let's talk about something that's, well, it's a huge shift happening in medicine right now. It's all about how doctors are learning to talk to AI. It's a brand new skill, and honestly, it might be just as critical as learning to read an x-ray. So, just to give you a sense of how powerful these things are, get this. These big AI models, or LLMs, can now pass the very same medical board exams that doctors spend years of their lives studying for. And it's not just about passing. Models like GPT-4 are actually scoring higher than many of the human doctors who took the exact same test. It's pretty mind-blowing. Okay, but here's the billion-dollar question, right? Passing a test is one thing, but the messy, complex, high-stakes reality of treating a real person, that is a whole different ballgame. So how do we actually bridge that gap? Well, the answer seems to be in this new field called prompt engineering. All right, so let's start with the good stuff, the promise. How could this technology actually change the day-to-day grind in a clinic or a hospital? Because the potential here is genuinely transformative. So what exactly is prompt engineering? Really, it's the art and science of carefully crafting the instructions, the prompts that we give to an AI. It's not just about asking a simple question, it's about structuring it with real precision. The best analogy in medicine is that it's like writing a detailed prescription. The more precise you are, the safer and more effective the outcome is going to be. And the kinds of tasks it can help with? It's pretty amazing. We're talking about automating all that tedious work, like writing discharge summaries, or helping doctors brainstorm what could be wrong in a really complex case. It can even draft patient education materials in clear, simple language. The whole idea is to free up clinicians to focus on what they do best, actual patient care. But, and this is a big but, here comes the reality check. While the promise is huge, the science behind all this is still in its very, very early days. A recent major review of 114 studies found that the field right now looks a lot like the Wild West. And when you look at how the research is being done, a really clear pattern pops up. The vast majority of studies, we're talking 78 out of 114, are all about what's called prompt design. That's basically just doctors writing prompts by hand to see what happens. The more technical, more rigorous methods, yeah, they're way less common. And all of this leads to a pretty shocking number, 61%. Let that sink in for a moment. So what is that 61%? That's the share of those common manual prompting studies that didn't compare the AI's performance to, well, to anything. No human expert, no older software, nothing. It's like declaring a winner in a race where they're the only one running. It makes it almost impossible to know if these methods are actually effective or if they're just a cool new toy. And the risks get even more serious. The review actually found 7 studies where researchers used the public version of ChatGPT with sensitive clinical data. I mean, wow. This just highlights a massive gap in understanding privacy and security, and it really underscores how new and, frankly, unregulated this whole field is. So, to make some sense out of this chaos, it really helps to break down the 3 main ways that researchers are trying to talk to these AIs. First up is prompt design. This is the one we just talked about, the most straightforward and by far the most common method. A clinician just manually writes out a detailed instruction. It's easy to do, it's intuitive, and it's pretty much the go-to approach in the research today. Next, you have prompt learning, which is a step up in sophistication. Instead of writing out a whole instruction, you create a kind of template with blanks, and then the AI is trained to fill in those blanks. Think of it like teaching the model a new trick for a specific task without having to retrain the whole thing from scratch. And finally, there's prompt tuning. This is the most advanced method of the 3. Here, the prompt isn't even made of regular words. It's a set of trainable numbers, a soft prompt, that gets optimized automatically by the machine itself to get the best performance. It's much less intuitive for a person, but it's potentially way, way more powerful. Okay, so knowing the risks and the different methods, how can a doctor actually use this technology safely and effectively, like today? Well, researchers have proposed a pretty clear framework. Basically 5 core rules for clinical prompt engineering. These 5 principles are really the foundation for using this stuff right. It's all about being incredibly specific, providing context, being willing to tweak your prompts over and over, always putting ethics and privacy first, and, this is critical, grounding every single question in evidence-based guidelines. You never, ever just blindly trust what the AI spits out. And this slide right here is a perfect illustration of that first principle, specificity. I mean, look at the difference. Asking a vague question like, what are the treatment options for diabetes, is going to get you a generic textbook answer. But crafting a specific, detailed prompt like the one on the right, that gets you a clinically useful, patient-focused response that actually takes guidelines and context into account. That precision is everything. So let's look at a few common techniques that actually put these principles into practice. These are the methods you see popping up in the studies all the time. The two most basic techniques are called zero-shot and few-shot prompting. Zero-shot is just what it sounds like. You ask a direct question with zero examples. You're just relying on the AI's built-in knowledge. But few-shot is where it gets much more powerful. You give the AI 2 to 5 examples of what you're looking for, teaching it the format and style you want right on the fly. And building on that, you have the most popular advanced technique in the research by far, chain of thought. It's so simple, but it's brilliant. You literally just add the instruction, think step by step to your prompt. This forces the AI to show its work, to lay out its whole reasoning process before it gives you an answer. This dramatically improves accuracy, especially for complex medical questions, and it makes the output way more transparent and trustworthy for the doctor. So, after all that, where does this leave us? What's the real takeaway for the future of AI in the clinic? I think the core message from all this research is that the power of these AI models isn't just in the tech itself. It's in our ability to guide them with rigor and discipline. Powerful tools demand a structured approach. And for these AI models in medicine, prompt engineering is that discipline. It's the framework that can ensure safety, accuracy, and reliability. Ultimately, this technology is a phenomenal knowledge tool. It can access and synthesize just vast amounts of medical information in seconds. But knowledge isn't the same as wisdom. So the final question we're all left with is this. As the AI provides more and more of the knowledge, what is the clinician's role in providing the wisdom?